Hello again, fifth grade. I'm going to go ahead and move along to lesson 79 in science with you. And this is going to be about Newton's laws of motion. So you might have heard of this before, but we're going to get into a little more detail with them. So it all has to do with forces in motion, which is what we've been discussing. Okay, so last time we talked about drag, which is resisting the motion of an object through fluid. Okay, so it's working against it. We talked about buoyancy, which works in opposite direction of gravity. It's how things can float. We talked about thrust, which is another opposite. It's going to push this direction to cause the object to move that direction. And we talked about lift, which is the force that lifts objects up. Like it'll lift a plane in the air. It'll lift those wings up. Lift helps that. It lifts up the leaves off the ground. Anything that's kind of lifted up. That's wind is a big thing that causes the force of lift. Okay, so now we're going to move on to Newton's laws of motion. And it is on page 11. That's where I'm going to start. And there will be some highlighting here. So if you have the physical copy of the booklet, go ahead and get out a highlighter and you can highlight along. And I think I told you before, if you have Adobe Acrobat on your device, if you open up a PDF in that, it's got a highlighting tool that you can use as well if you'd like to highlight that way, or just read along. Okay? So when forces are unbalanced, so we talked about a balanced force is just going to be sitting still. That's the normal force where it's just balanced and it's sitting still. If it's unbalanced, there's going to be some movement happening. So it's going to cause motion. Okay. So on paragraph 1, it says in 1687, Sir Isaac Newton stated 3 laws that describe how forces affect the motion of objects. Newton's 3 laws are based on his observations of the relationship between objects and forces acting on them. So just a side note, a scientific law is a detailed description of a natural phenomenon. Laws describe the phenomenon, but not how or why it occurs. In physics, laws often are mathematical formulas. A scientific theory is an in-depth explanation of how or why an observed phenomenon occurs. Okay, so a law is a formula stating like if this happens, then this happens. So when you get into high school and you take physics, you'll learn more about the different laws of physics. So like E equals mc squared that you've heard from Albert Einstein, that is a law. Okay, actually that's the theory of relativity. But anyway, the scientific formula, if it's a for sure thing, that's a law. If it's a theory, just means something that it's not proven. It's just a detailed explanation of why something might be happening. Okay, and so these are laws of motion. So they're proven that if you do this, then this will occur. So that's why they're called his laws of motion. They're not just theories, they're laws. Okay, so the first law of motion is in paragraph 2. It says Newton's first law of motion states that an object at rest stays at rest until acted upon by an unbalanced force. So a book on a table will not move unless a force causes it to move. The first law also states that an object that is moving will continue moving in the same direction and at the same speed unless an unbalanced force acts on it. Okay, so another way to say this, I always learned an object at rest stays at rest unless acted upon by an outside force. An object in motion stays in motion unless acted upon by an outside force. Okay, so if this book is sitting on a table, it's not going to move unless I push it or if I move the table or something like that. So it's going to stay at rest unless a force acts on it. And if something is moving, like a ball rolling on the ground, it's going to keep moving at the same speed until friction acts on it. Okay, or until somebody physically stops that ball from moving, it's going to keep moving. Most of the time, friction is going to stop it. Or if you're playing catch with somebody, they're going to stop the ball with their hands. But it's going to stay in motion until some force stops it. Okay, so in the first sentence, you're going to highlight the words Newton's first law of motion. Okay, Newton's first law of motion. And then after that, You're going to basically highlight almost the entire paragraph on this one. So you're going to highlight the words object at rest stays at rest until acted upon by an unbalanced force. So it's saying if it's resting, it's going to stay resting until a force acts on it. Okay, so highlight the whole end of the first sentence. And then in the third sentence, you're going to highlight the end of that also, where it says object that is moving will continue moving in the same direction and at the same speed unless an unbalanced force acts on it. Okay, so that's all the first law. If it's at rest, it's staying at rest until a force acts on it. It's moving, it's staying moving until another force acts on it. Okay, so that's the first law. That's why we wear seat belts with a shoulder strap in cars. Okay, because if the car is moving and you're moving with the car, you're going to keep on moving unless a force stops you. Okay, so if something stops the car, your body's not going to stop unless a force is stopping you from moving. That's why we wear seatbelts. The seatbelt is the force that stops you from flying out the front of that car if you get in a car wreck. Okay, so like I said, the direction and the speed of the people in the car is not going to change unless a seatbelt stops it. Okay, paragraph 3 is going to tell us more about that first law. So Newton's first law of motion is also called the law of inertia. Inertia is an object's resistance to a change in motion. Objects with more mass need a greater force to overcome inertia and start moving than objects with less mass. Okay, that's the law of inertia. So the bigger the object, the more mass it has, it's going to be harder to start moving and it's going to be harder to stop it from moving. That's the law of inertia. Okay, so at the beginning of the second sentence, highlight the word inertia. Pause it a second for my dog. Okay, my dog had something important to say, so we had to stop for a second. Okay, so at the beginning of this second sentence, we highlighted the word inertia. Okay, so if a car and a tractor trailer have stopped at a red light, it takes more force for the tractor trailer to start moving than for the car to start moving, okay? Because the tractor trailer is going to have more mass, okay? So paragraph 4, we're going to talk about the second law of motion. Newton's second law of motion states that the acceleration of an object depends on the mass of the object and the strength of the force that acts on it. An object with less mass will accelerate or gain speed at a faster rate than an object with more mass if the same amount of force is applied to both. If different amounts of force are used to move two objects with the same mass, the object that is moved with a stronger force will accelerate more quickly than the object that is moved with a weaker force. Okay, so this is all about acceleration, which means gaining speed. So if you drive a car, to make it go faster, you hit the accelerator. And if you have a tiny little sports car, you're going to go much faster than if you're driving a semi-truck. Okay, because the semi-truck has more mass. So it's harder to accelerate the semi-truck than it is the small sports car. Okay, because it has, more mass. It's easier to accelerate. And if they have the same mass, if you use a stronger force, it's going to accelerate quicker than if you use a weaker force. Okay? So he's kind of just stating the obvious that we all know right now. If you want to move a bigger object, you need more force to make it go faster, right? That's basically just what he's saying. So in the first sentence, highlight the words Newton's second law of motion. Newton's second law of motion. And acceleration actually occurs when there's an increase in speed, just positive acceleration. A decrease in speed is negative acceleration, or a change of direction too. Okay? So the next part you're going to highlight is the second law of motion itself, all about acceleration. So in the first sentence, highlight the words acceleration of an object. depends on the mass of the object and the strength of the force. Okay, so I'll hold into that first sentence. So the smaller mass, the easier it is to accelerate. The stronger force, the more acceleration you're going to have. So if you've heard the phrase, put the pedal to the metal, that's if you're pressing the accelerator in your car all the way to the ground, you're going to go faster than if you barely press the accelerator. That's kind of the point of the accelerator in your car. Okay. So, and then we would have had a demonstration with soccer balls. So if I kick a soccer ball harder, it's going to go farther than if I barely kick it. That's the second law of motion. If you have more force, it's going to go farther and it's going to go faster. Okay, so the formula for the relationship between mass and acceleration is F equals M times A. So force equals mass times acceleration. And you'll get into more of this in high school physics too. You'll have to calculate the force of different objects. But if the force is equal, an object with more mass will have less acceleration, and an object with less mass will have greater acceleration. So it's basically just the formula for the second law of motion. Okay? So paragraph 5, we're going to talk about the third law of motion. Newton's third law of motion states that every action has an equal and opposite reaction. The gravitational force pulling a book downward on a table is the same amount of force the table exerts as it pushes upward on the book. So it makes it balanced, right? When you stand on the ground is pushing up on your feet with the same amount of force as the gravitational force pulling you downward toward the ground. If you push against a wall, the wall pushes back with an equal force. Okay, that's how everything kind of balances out. If somebody's pushing this way against the wall's pushing right back at you. Okay, every action has an equal and opposite reaction. Okay, if you've seen one of those, I can't remember the name of them right now, those little things where the balls are hanging down, the silver balls, and you click one and then it goes on the other side and clicks back and then goes back and forth. That's the reaction. So if you make the ball go this way, it's going to hit these balls and make that one go out. That's the reaction. And then it's going to swing back and come this way. So every action is going to have a reaction. Okay? So in the first sentence, highlight the words Newton's third law of motion. And then you're going to highlight what that is. So every action has an equal and opposite reaction. Okay. And there is actually a video I'm going to post of this one too, a YouTube video. You don't have to go to there is one on the Nancy Larson website, but I'm pretty sure it's only under the teacher resources. So I found one on YouTube that I think you guys will like on Newton's laws of motion. Okay. So after you're done highlighting and everything, the lesson review for this isn't going to be due until the next week. But if you want to go ahead and get started on it, I'll go ahead and post it now. You can get it done ahead of time. All right, see you in a bit.